This video will explain about normal approximation to the binomial distribution. Previously, we know that the binomial distribution is a discrete distribution. However, the normal distribution is a good approximation to the discrete distribution when it is bell-shaped. Thus, the normal distribution can be used to approximate binomial distribution. So here, if x is a binomial random variable with the parameters n large and pi is not close to 0, then x can be approximated by a normal distribution with the mean mu, which is np, and the q is 1 minus p. The variance is npq. So we have the x distributed as binomial, np can be approximate to the normal distribution with np and pq. The approximation is excellent when n is large and fairly good for small value of n if p is reasonable close to 1/2. We will use the normal distribution to approximate the binomial distribution when the value of n multiplied with p greater than 5 and n multiplied with q is greater than 5. But there is a slight inconvenience because normal distribution is continuous, but binomial distribution is discrete distribution. So, a continuity correction factor of plus minus 1/2 must be applied when a continuous distribution is used to approximate discrete distribution. The approximation from discrete to continuous, a correction factor plus minus 1/2 should be applied. This is because, okay, as you can see here, the square shape is the binomial probability distribution function, while the curve is normal probability distribution function. So, for example here, if you want to find the probability of x greater or equal to 1 to approximate probability x greater than 0.5 to include the area of rectangle for x equal to 1. Next is, for example, you want to find the probability of x greater than 2. So you need to approximate to probability x greater than 2.5 to exclude the area of a rectangle x equal to 2. And if you want to find the probability of x equal to 3, so you need to approximate to probability 2.5 to x and less than 3.5 to include the area of the rectangle for x equal to 3. So in short, if you have the a and b two integers, probability x greater equal to a, so you need the value of a, you need to minus 0.5. If probability x greater than a, so the value of a plus 0.5. If the probability x less or equal to a, the value of a plus 0.5. If the value of x less than a minus 0.5. If you have the probability of x greater or equal to a and less equal to b, a minus 0.5 while b plus 0.5. If you have the value of x between a and b, so a plus 0.5 and b minus 0.5. If a probability of x equal to a, therefore, the probability of x a minus 0.5 to the x a plus 0.5. So let's relook into the example. Tomorrow morning, Malaysia Airlines Mass MH18 flight to Shanghai can seat 370 passengers. From the past experience, must known the probability is 0.9 that a given ticket holder will show up for the flight. They have sold 400 tickets, deliberately overbooking the flight. How confident can must be that no passenger will need to be bumped? It means that denied boarding. So from here, we have the total passengers is 370 and the P is probability of success is 0.9. Now assume that the X is passenger showing up for the flight has a binomial distribution with the mean mu and multiply with P. So the total number of sold is 400. So 400 multiplied with 0.9, 360. And the standard deviation is square root NPQ. So you will get 6. Now, you want to find the probability of x less than equal to 370. So approximate Since this is less, so the A must be plus 0.5. So you will have to find the probability X less than 370.5. So approximate to the standard normal deviation, which is X minus mu 370.5 minus mu 360 divided by standard deviation, which is 6. Then you need to find the probability Z less than 1.75. So we know that the area, in order to find the total area for Z less than 1.075, the total area 1 minus the probability of Z greater than 1.75. So based from the statistical table, probability of Z greater than 1.75 is 0.0401. So the probability of X less than 370.5 is 0.9599. Next example, according to the statistic report released by the Malaysian Highway Traffic Safety, show that on average, 4 out of 10 drivers on the road had been involved in accident on weekends. If 100 drivers are randomly checked next weekend, what is the probability that the number of accident drivers will be less than 32, more than 49, at least 35, but less than 47? So the first question is, the N here is 100. Okay, sample size is 100, and probability of accident happen during weekend is 4 out of 10. So 4 divided by 10 is 0.4. So X is the number accident drivers on weekend. So the mean N times P, you will get 40, and the variance is 100 multiply 0.4 multiply 1 minus 0.4, which is 24. So X is binomial distributed with 100, 0.4, but approximate to the normal distribute, which is 40, 24. Okay, the first question is the probability of the drivers involved with the accident less than 32. So Px less than 32. So you need to minus 0.5 with the continuity. Alright, so probability X less 31.5. So approximate to the normal distribution, 31.5 minus mu divided by standard deviation. So you will get the probability Z less or equal negative 1.74, since our statistical table is on the positive sides. So it's actually equal to probability of Z greater or equal 1.74. So from the table, you will have the probability of Z greater or equal to 1.74 is 0.0409. Therefore, the probability the driver involved accident during weekend less than 32 is 0.0409. Okay. Second question. The probability of the driver involved in accident more than 49. So, we use the same binomial and approximate to the normal distribute with the mean 40 and the variance 24. So you have probability X greater than 49. Since it's greater, you need to plus 49 plus 0.5. So probability of X greater than 49.5 approximate to the standard normal distribution, 49.5 minus mean divided by standard deviation, then you will have probability of Z greater or equal 1.94. So from the normal table, you will have the probability that the drivers involved in accident more than 49 is 0.0262. Next is at least the probability of driver involved in accident at least 35 but less than 47. So it means that the probability of X greater or equal 35 and less than 47. So approximate with the continuity continuity, 35 minus 0.5 and 47 minus 0.5. So you will approximate to the standard normal deviation, standard normal distribution, which is 34.5 minus 40 divided by square root 24, 46.5 minus 40 divided by square root 24. So you will have to find the total area Z greater or equal to negative 1.12 less or equal 1.33. So as we learned before, in order to find the probability that involve negative and positive sides, the total area 1 minus the total area greater than 1.12 minus the total area greater than 1.33. From the table, you will have the value of probability z greater or equal to 1.12 and probability of z greater or equal to 1.33. So, the probability of the driver involve accident during weekends at least 35 but less than 47 is 0.7768.